All right, so for this lecture, we're going to take a look at the adrenal glands as well as the pancreas. We're just going to look at the gland and the hormones they produce for this section. So we'll start with the adrenal glands. There are two actual glands within the adrenals themselves. The adrenal glands are these little organs that actually sit on top of both of the kidneys. So they're a paired set of glands. There is the cortex, which is the outer layer of the adrenal glands, which is glandular. And then there is the medulla, which is an inner layer, which is more neural types of tissue or nervous tissue, right? And they both secrete a little bit of some different hormones. So we'll start with the cortex. So on the outside of the adrenal glands is the cortex. It secretes a hormone called the mineralocorticoids, or also known as aldosterone. Um, these are used to help regulate both water and electrolyte balances in our blood. And what they do is they cause the kidneys to reabsorb sodium as well as water. So when we have production of that, it's going to allow the kidneys to pull more water out of our digestive system and put that water back into our bloodstream, so increasing the blood volume. The production also stimulates an enzyme called renin. Renin is actually what is made by the kidneys, and it happens when our blood pressure is low. So the whole idea here is we're trying to put more water back into our cardiovascular system um, to increase the volume, which will in turn increase the pressure. So the stimulation of that production of aldosterone causes the reabsorption of water and then increases our blood pressure pretty quickly. So that's one of the ways that we can do that. This just kind of shows how that process takes place. So again, you have an increased absorption of water here in the kidneys, which increases the blood pressure. But what you actually have is a decrease in sodium and calcium in the blood. So you're going to pull that out, and then a decrease of volume in the pressure. This is where that trigger of renin happens. So that when the kidneys notice that there's a decrease in both volume as well as pressure, they secrete this renin that then tells the adrenal glands to produce that mineralocorticoid, specifically aldosterone. All right, but the whole purpose here of mineralocorticoids and aldosterone is to increase blood volume and pressure via increasing absorption of both sodium as well as water. Right. Another one then that is secreted by the cortex, so the outer portion is a glucocorticoid, all right? And the big thing here is if you remember the name of it, gluco, and even if I go back to the mineralocorticoids, so this really tells us what they do. So mineral, think sodium, all right, because that's a mineral, and glucocorticoids, gluco is glucose, so glucocorticoids are both cortisone and cortisol. These are our stress hormones, actually. Um, these help us resist long-term stressors. So if you're under enormous amounts of stress, this pandemic could really cause that for a lot of people. What it will actually do is suppress inflammation as well as decrease edema in the body. What it does, though, is it increases our blood glucose levels. Um, and this is in response to this ACTH, the adrenal corticotropic hormone produced by the pituitary gland. All right, so we talked a little bit about that when we talked about the pituitary gland. All right, so when this happens, people can have not huge amounts, but increased levels of actual blood glucose. So it might look, if you were to take a blood sample from a person who's under the kind of long-term stressors, it might look like they have the start of diabetes, which we'll talk about here in a second. But what they're actually going on is because their body's under this stress response, they're producing more of this glucose because they're trying to prepare themselves for fight or flight, right? Because these cortisones and cortisols are fight or flight, some of our fight or flight hormones. These are some of the things that they'll actually cause. So they'll cause a retention in sodium as well as water by the kidneys, and they will increase blood pressure. All right. So again, we might see an increase in blood pressure because of these mineralocorticoids, whereas the glucocorticoids, we're going to see both protein and fats converted to glucose and then broken down and used for energy. And an increase in both blood sugar as well as these people sometimes, because of this release of these, can actually suppress our immune system, which is one of the reasons why when people are under long-term situations of stress, they can be more susceptible to disease, specifically flus or other types of disorders that can happen because the immune system has been suppressed. Okay, this just shows you the flow chart for those. Kind of skip over those real quick. All right, the cortex itself can also secrete sex hormones. So they're produced mostly by the inner layer of the adrenal cortex, and the main one here is androgen, which is testosterone for males, and estrogen, which is the hormone for females. Okay, skip over that. So hold on, let me go back 1 second. Sorry, guys. And I went too far. Nope. Okay, so androgens are producing all those secondary sex hormones that are sex characteristics that we associate with being male. So body hair, bone density, deepening of voice. All right, they'll also start to bring online the testes to produce sperm, and then estrogen. We think of all those secondary hormones for women. So breast enlargement, hip widening, increase in fat. Layer increase in fat deposits in the body. Those are big things that estrogen can kind of cause, as well as bring online the ovaries. Okay. Um, Now we're going to talk a little bit about the medulla. So this is the inner portion of the cortex. So this one is mostly nervous tissue. So we have epinephrine and norepinephrine. All right. So these were the ones that prepare the body to deal with short-term stresses. These are also some of our fight or flight hormones. Okay. So they're going to, a couple things here for short-term stress response. So we're going to see an increase in heart rate, which will increase pressure. All right. We're just beating faster. So we have more pressure in the system. The liver will actually start to convert glucagon back to glucose. All right, because again, we need all this energy. We'll have a dilation of both bronchioles as well as dilation of blood vessels. Okay, changes the blood flow patterning, so we have an increase in blood flow to alertness, and it also decreases the activity of both the kidneys as well as the digestive system. And then we have an increase in metabolic rate here in this case. Okay, this just kind of shows how this basic process takes place. For now, we're going to move on a little bit to the pancreas. So in this case, we're looking at the pancreas itself. It's a mixed gland, so there's a couple different things that go on in here. Number one, there are what are called beta cells inside of the pancreas, inside of what are called the islets of the pancreas. They produce two hormones for us, and they're both in response to glucose. One of those is insulin. So insulin is what actually allows glucose to cross the plasma membrane into cells, and the other one is glucagon, which allows glucose to enter the blood from the alpha cells. These hormones, like it says here, work as antagonists. So if we have an increased level of blood glucose, we have a secretion of insulin. If we have a decreased level of blood glucose, we have a secretion of glucagon. So insulin causes a take up by the cells of glucose, and glucagon causes a take up, especially by the liver, to process that. All right, so this just shows the basic process here. So the pancreas, and just shows the islets where the secretion of those happen. All right, and then this is the basic homeostatic mechanism for glucose. All right, we use this a lot when we talk about homeostatic mechanisms in biology, but we've seen this a couple different times here. So this is normal blood glucose, somewhere between 90 to 190 grams per 100 milliliters. So when we take somebody's blood glucose using a monitor, we should see if it's normal, it'd be pretty close to 90. If they've just eaten, obviously now it's going to be more than that. If they haven't eaten for a long time, we can see a decrease in that. All right, but if we get an imbalance of this, so this is our elevated blood glucose levels. All right, we'll have insulin secreted, which is going to cause two things. It's going to cause the cells of the body to take up more glucose, and it's also going to cause the liver to store that glucose as glycogen. All right, those two processes, the uptake by cells and the storage by the liver, will cause a decrease in blood glucose, bringing us back to that level of 90. Now, if we go the other way, so we're above or below 90, this is a declining blood glucose. So now this person hasn't eaten for a while. We're going to see low sugar levels. Now, instead of secreting insulin, we're secreting glucagon. And the idea here is the glucagon is going to target those cells in the liver, causing the liver to release glycogen and turn it back to glucose. All right, dumping all that glucose into the blood now raises our blood glucose level, hopefully bringing us back to, all right, this process back to normal homeostasis. The same thing can happen for people who have like type 1 diabetes, except now they have to monitor it. Their pancreas doesn't do that for them. All right. So now if they eat, they have to take their blood sugar and then give themselves enough insulin to bring themselves back to zero. If they haven't eaten in a while and their sugar is low, they have to eat something, all right, to do that process because they have to bypass the pancreas because the pancreas isn't working for them. Okay. All right, we're going to stop here. I'm going to use the conditions in another lecture, okay?